Hey students, Robert K here, the new environmental science teacher. A couple of questions and requests from students to clarify some things about the Energy Audit Project. And one thing I noticed is that not all of this stuff has even been put in Google Classroom. Y'all are being very patient with the teacher churn, different teachers in and out. So I'm going to try to bring some organization and clarity to this. These are all the things that you classroom. There's some other things that have been printed out. One student was justifiably complaining about getting papers and paper instructions. So for the electricity audit, I think the hardest part is going to be going around your house and finding these weird little tags on different appliances. I find this a very daunting task. I've looked at a few things in my own house and I'm like, oh my God, I'm not going to go around and look at every single light bulb. So that's really challenging. And then some other people were challenged by the calculations. I find this less challenging, and I hope I can make it clear to you too. But basically, you're given this example, and it's trying to get you to practice converting the data to make sure you know how to convert it. I think as long as we understand why we're converting and how the conversion works, what operation to use, we really don't need to practice doing mental math with a paper and pencil, right? This is senior year of high school, and you all get out of your high-paid data analysts, hopefully working on something that helps with climate change. So we need to learn spreadsheet skills about penciling. And if you've already done that, great. Practice mental math. I built a spreadsheet for you guys. You're going to help me complete it actually in class. That will do a lot of this calculation for you with nice little formulas. So I'll tell you when data is missing. So this is for flying. And I actually nerded out about flying, and there's some other things about it. Let's not talk about that yet. But let's start with electricity. So I literally just put this exact same table from your assignment. Just took this little practice table here and put it into here. And so we can start with practice data. And then you could just use, instead of filling out this whole sheet and doing all these tedious calculations on this big piece of paper for your own appliances, you can simply put them in here, right? You can just add new rows in your house. And then all you have to do is put in watts, amps, volts. And the watts, notice it's a formula. See, there's a little formula up there that's calculating watts is amps times volts. The little star is how you do times in spreadsheets, right? Shift 8. You always have to do an equal sign for equations, but we don't have to type the whole thing over. You can literally just go like this, shift down, arrow down to highlight, and then control D to fill it down. Or you can go like this for another formula. There's a formula. Drag it down. If I put my mouse in the corner, it turns a little crosshair, right? It's a hand, it's a crosshair. Drag it down, does the same thing. Drag it too far. Okay, so this also will calculate for you these things as well. Just drag this down. And so when you make a new line, just drag everything down like this, down for your multiple VM system. Yeah, so that's how that works. And then I think you could also, if you estimated something in hours per day, then to get the minutes, instead of taking the minutes and dividing by 60 to get the hours, you could also take, like here, I took the hours and times by 60 to get the minutes. So it doesn't matter which one you do, get the idea, right? Or multiple ops, in case you forgot from grade school. So again, you don't have to do all the math, understand the operations, how they work, why all unit conversion is. It gets really tricky when you are trying to overload your brain with full math at the same time. There's no reason to use spreadsheets. Okay, I've beat that dead horse enough. Forget about this. We're all going to put our data in here in class. You've already done this. Great. You got the mental math practice, but tomorrow we're going to all put our data in the same sheet, and then we can do nice little things like taking averages. So I need to put a name next to this so we know who is who's going to make sure that you completed this. So I did this for the car one. In industry, we talk about power, automotive, and aviation targets, right? So that's electricity, that's cars, and that's planes. Different words for it. So I'm just going to use the industry terms because the world from it. Think about how you're going to fit into that world as well. We're all going to be dealing with decarbonization stuff in our lives. So here's me. If you were you would put your name, your period, I don't know which period you're in, 5 or 6. You have multiple cars, but you could do 1, 2, put your name again, right? Same person here. What they are, make, model, year. And I like to put a source of where you got the mileage from. I like current source. There's official mileages, fueleconomy.gov, really easy to remember. And then you can put, I haven't done this yet, as you can see, but minus mileage, let's say it's 100,000. And that for 24 hours, 100. Let's format these a little differently. I want to be able to see the commas. Those ones. I'm just going to dollars. Point there. Now it's a little easier to see. 100, drove 1 whole mile that day. Or I could just go like this, equals plus 1. I drove another mile the next day. Look at that. Maybe I drove 100 miles the next day. Look at that. My driving is really, and my average MPG, oh, I need to do, okay, so how would I get the miles traveled? After 48 hours, I would need to do odometer after 2 days minus where I started. There we go. Why is that wrong? Wrong thing. Yep, I subtracted the wrong cell. Did not want it to G2. Here we go. I drove 100 miles. 1. And look, it's all calculated for me. Skippy, skippy, right? Take that away. I'll go back to 0. Back. It's all for me. I don't need this many decimal places. Let's take some away. Oh, I need decimal place. All right. So that's it. Annualized. How did it annualize it? Oh, God. Multiply it. Remember, it's a 2-day thing, so I multiplied it not by 365.25, which is the number of days in a year, counting leap years, which happen every 4, right? After day every 4 years. So I divided by 2 because we're talking about 2 days. Actually, half that many periods in a year, right? If I'm talking about a 2-day period, there's not 365. There's only half that many. It's a 2-day period, not a 1-day period. That's why the by 2 there. Members, and then that's taking how many people in my family and dividing the annual gasoline usage by the number of people in my family to get the annual usage per person, right? Per capita or per person per year gasoline use. Okay, so that's all how that works. You don't have to do any of this. Again, all you have to do is fill the formulas down. In fact, you could just fill the entire row down and change the things that you need to change. Let's say you have 4 people in your family. Let's say your car gets 40 miles a gallon, hybrid or something, and you change the car, the name, obviously, right? You're not a teacher, you fix all that stuff, you fix this, where it was, you drove 10 miles on the first day, on an autofill, be somebody else down there. But all the second day, it's your source, right? You can click on this and then find your car, whatever it is. Maybe it's not a Toyota Corolla, maybe it's a 20 Acura. So I can just get my car that way and add in there, copy and paste the link. Pretty or not, I don't care. It's that. The power thing, if you are totally intimidated by finding all of these power things, all these appliances, here's a little shortcut. Pacific Gas and Electric, as we were discussing, has a monopoly. Your folks who presumably pay this bill can log into their account or find a paper bill lying around, and you can actually see all these helpful things. I don't like paying this much for electricity. I need to figure out how to cut back. And this is actually a problem in my life. I literally saw this bill and I was like, oh my God, that went way up. What's going on? And I'm not going to go around looking at every single light bulb and writing down the amperage. Okay, I'm just not going to do that as a real person in the world with this. And you shouldn't either. You can if you want as an academic exercise. And if you were seriously auditing yourself as a company, right, you would have like records, all the light bulbs you purchased and stuff like that. And so you could figure those things out from that very bottom up granular way, because you would have records, all those things, probably, we hope. But going around the house and counting light bulbs is really tedious, okay? And light bulbs use minuscule amounts of energy. So do electronics. It's really negligible. So what's going to use a lot is heating elements, anything that's turning electricity into heat. So dryers, stoves, refrigerators, same thing. Running a compressor, right? It's running a motor of some sort. That's what's going to use up the electricity mainly. So I would start with those things if you want to figure out. And it's going to tell you this sort of thing. Learn how you use energy, how you can save energy. It's going to give you some stuff, and it's definitely going to give you your total usage in here. So fill out their little quiz. Apartment, I own my home. Size in square feet. Small place. Anyway, this is all about heat, so a whole different thing. So this wants to know about, are you using electricity to heat your home? It's going to be a major thing. I'm pretty careful about it. So notice it's going through. These are going to be the main ones. These. Okay. So obviously this is based on the questionnaire. So this is like kind of an estimate. Basically they're saying my water is probably the biggest. I wonder if I'm paying for that since the apartment pays for that actually. But heating, did I still have my electric heater? Funny. I would have thought my stove would be more than this. Anyway, like this to go. I want to see my actual use first. Yeah, this was 62 of that with electricity. Ask and warm, brace, cost increased. I want to see my usage. There we go. So you want to go to Energy usage details and electricity. And that'll give you your kilowatt hours. Can you download this data? Doesn't look like there are a few the whole year here. I haven't looked here very long. But this is better because it's a monthly number. Average these out. Interesting, the average temperature. It seems like my usage actually goes as sure goes up more or less. Why is that? Maybe power, run an air conditioner. Probably we're running more fans than most. We do run a fan sometimes. Printer likes to run the fan. It's too hot easily, whereas I'm a cold person. Oh, look at there. Download my data. All right. Download the sucker. Let's put it in the CSV. That's basically a spreadsheet. Oh, almost. Wait. Use it. Is this just me? Money number. Let's see. Project in my little list. Just diagram transit, which is relevant to what we're doing. I'll check that later. Okay. All right. And this is thanks to these things. My other I'm working on. Okay. Yes, it gives me a kilowatt hours. Great. Yeah. Okay. So we just need this part. Grab that. So here, I'll put this in the now. Faster or and paste. I'll be. Here's what we do. More data, so I'll put it over here. So, this is all. This gives you the fraction of a year between two dates. Okay? Start date, end date, handy dandy. We don't need that. Fraction of a year. Fill it down. Control D, Alt / for format percent of the year it is. Call it 2 people. Family size. My family size. Dog, but she doesn't count. What per capita? Oh, this isn't done here. This is just percent of the year. I need, that's the fraction, right? So I use this much. So what do I need to do to get to annualize it? I need to divide it by the fraction of a year that it is, right? So I used this much, not per year. Remember, per is a divided by, right? This much per 3% of a year. Now I don't actually the percent of these and number, whole number, delete decimal number. Okay, fill it down. There we go. Always yearly total usage divided by the number for the per capita. And there I can say yes, please autofill. Just fill for each row. Everything the row that's on and decimals. Okay, so done. There's my usage. So notice that if I take a given month of data, I'm going to get a different, and I annualize it, I get a different number, right? So what should I do to get a better number? Average them, right? I just suggest it. Nice. Well, first is practice. Oh, or something. Okay. For those. Yeah, so really, 906 kilowatt hours per person per year, or 1,800 per year. How does that compare? We'll find out. And this is much better data than just my estimate how long I have to log. It's the actual usage, right? This is real data from the people who get paid to count it. You could sanity check it. You could reality check PG&E by going around and counting all your light bulbs and trying to do the calculation this way. But frankly, I think they have a financial incentive to be pretty accurate with this, and they have the capacity to do everything. The meter data, I think they're probably more accurate than you are. Why they wouldn't be. Although, funny story, PG&E did forget to bill me for 8 months, so that was nice. Haha. I moved in and they had the records wrong. It's a bunch of free electricity. Thank PG&E. They never came back after me for it either, which is pretty cool. But like I said, they're a company that's had their problems and continues to have their problems. But I think they probably know better than I do power I used. In a month, they charged me for it. Okay, so that's that. I would highly suggest that you do this. After I do this, maybe I should put this in the comment sheet. Say this, use the method as for your analysis. Paste to at last row. Later, get your PG and as I'll also link. There we go. Okay, so here's my suggestion to do this. Now, if we want to talk about aviation, this is much more complicated. complicated because I've looked into it and the official way to measure stuff. So a lot of calculators online just measure a straight line distance between airport A and airport B, and that's how long you flew. And they take an average gallons per mile because planes use so much measured in gallons per mile instead of miles per gallon. They assume 5 gallons per mile flown, times that by the distance, and there's your fuel usage. However, I don't love that. Notice that if I have this yellow data point, I'm going to use that because this is better. This comes from a company called PG&E. They have an API which you can plug into and grab data from their proprietary database. I'm talking to them on email to see if we can get free educational access because you normally pay quite a bit for this data. But this is a much more accurate way of calculating all the different things that make a plane more efficient or less efficient, like how full is the plane, right? How many seats are on it? What size? What type of fuel is used? There's a whole bunch of other things that go into that. The official way that these emissions are calculated by some international aviation group that I looked up, it's so simple as like these consumer online calculators. They're just miles times gallons. Well, it's a bit more to it than that. So hopefully we'll get to it. It's fine to just do the miles times gallons for now. You need to put those in. I don't know what this is. I'm just making this assumption about how much emissions per gallon. And actually I have a table based on that. I think jet fuel is kerosene, right? So this says kilograms of CO2 per gallon, right? We'll call it 9.8. But again, there's going to be a bunch of other niceties to this. It's not going to be that simple. But anyway, per gallon. This would be, so numbers on the flight. Say there's one. Be real there because we need more decimal. It's only one person. See, it's a tiny little percentage. Yeah, that'd be a percentage. The number. What are the units per kilograms of CO2? Kilogram. G. And really, we should be doing CO2e, carbon dioxide equivalent, taking into account other greenhouse gases besides CO2 that an air emits, but that's not the units we're in. And so it's going to be higher if we take CO2e, and that would be a more accurate estimation. I believe that the API data from Aviation Edge will give us an edge, so it'll take that sort of thing into account. So that's the kind of nerdy deep dive that you need to go on if you actually want to get this stuff right. And we need to get it right because people need to be held accountable for their emissions so that they have an incentive to drive them down. It takes a lot of nerdery, but when you get stuff calculating and you have all this data and you have to do math with a pencil and you can learn things about the world and use that to change the world, it's pretty empowering and cool. And plus you can get paid a lot of money to do this stuff. Hopefully you can build some skills, some fun, and learn some energy. I will see you in class. Hope this was helpful.